Great. Well, thanks for having us today. We're really looking forward to this. What I'm going to talk to you about, thanks for the great introduction, Babar and Hijam, is protecting cloud native applications. And what we mean by protection, quite simply, is backup and recovery. So during the talk today, I'd like to go through a little bit about the application evolution, because it's important to understand how we got here and why Trilio was founded for cloud native applications and cloud native platforms, for that matter. And so we'll talk a little bit about application evolution, how that ties into platform and infrastructure evolution. And then we'll also talk about application protection challenges quickly in the beginning, just a level set. And then we'll talk a little bit about the Trilio difference, really why was the company founded? And then I'll tell you about our specific application and our protection methodology for Kubernetes. And then we'll talk about Trilio for Openstack. So the evolution of architecture, there's probably quite a few people on the phone. I don't know if you're as old as I am, but I remember the days back when everything was run on bare metal servers, and there was no real virtualization technology. Although you can certainly argue it existed at the time. But what we're thinking about is a lot of monolithic applications. And for the longest time, probably really up until, I don't know, mid to late 90s maybe, this was the way that applications were run in environments. So you had lots of bare metal servers, and anytime you wanted to scale up an application, it was, do I go through the pain of trying to split this application up and find another physical server to run it on? Or do I find a larger server and migrate my application over to that server? And that is a pretty painful thing to do. It's difficult, and it takes a long time to procure the resources for a new application. So along came virtualization, right? So the days of VMware and Citrix Xen hypervisor and other hypervisors out there as well, right? Linux KVM. And it made the provisioning of servers much easier, right? Because I have a pool of physical resources, and now I can carve out a virtual server from them that looks a lot like a physical server. But really, that's most of the benefit that was gained from virtualization. And so for a long time, this powered new levels of cost reduction, really, in IT. But there was a point where networking became so ubiquitous and was so available to everyone that cloud platforms started to come along, right? And really, in my opinion, the real first cloud platform was the release from NASA and Rackspace of Openstack, right? This was the first time where, as IT practitioners like ourselves had the ability to get a platform that really was cloud first. And really, the evolution that happened from virtualization to cloud was, of course, cloud takes virtualization because you need that logical separation of resources from a pool. But it took that software-defined physical server that virtualization was, and software-defined almost everything else that you need to provision. So it wasn't just about a server resource anymore. It's about all the services of the cloud. And it's putting an API in front of them and also an orchestration engine. And this was very powerful because now you had the ability to provision things like networking, the physical server, image repositories, file repositories, production storage, in the form of block storage. And really, this transformed everything, right? The cloud platforms were super powerful, and we're still seeing people transitioning to these type of resources today, right? Amazon's growing every day, Google's growing every day, Microsoft Azure's growing every day. But the next evolution of this was cloud native platforms, right? So, you're thinking about this is the inception of really what Google started with Borg, which then became Kubernetes. And now it has changed the face of application development and the use of IT as a strategic business resource inside of most companies. And I think there are a lot of enterprises today, a lot of small companies that are all trying to get to the place where their applications, their infrastructure can be cloud native. And the reason is that Kubernetes provides a lot of the resources infrastructure, procedures, and self-healing abilities that most companies desire, because nobody wants downtime of their applications or their infrastructure for that matter. But with Kubernetes, you have the ability to schedule, right? You have a full control plane. You have APIs. You also have the ability to extend the platform, which I'll show you how we've done it with Trilio Vault for Kubernetes, to provide other services. And not only that, once you provide your services, once you define your objects, the infrastructure itself will self-heal your application. You give it a defined state, and now Kubernetes will take care of making sure that state is actually applied inside of Kubernetes. And anytime there's any problem with your application, it will automatically move it around, self-heal, roll out a new version of the container. It's an extremely powerful platform, and it's along brought with it a whole different way of developing applications. But when we're talking about developing those applications, it's difficult to protect them. I think a lot of the way people think about applications today when it comes to cloud native platforms is everything's stateless. I can just spin it back up. But what we've seen time and time again is that companies are desiring a way to protect their business, because you don't know what you don't know. And nothing is perfect in life in general, right? We all strive for perfection sometimes, but we never quite get there, right? It's a zero-sum game. So companies really want to know that their critical applications and their critical data is being protected no matter what foundation it's running on in this case, whether it be, a cloud native platform like Kubernetes, or it's a cloud platform, like Openstack. And so the way these applications really have changed is they've gone from a very defined state, from a rollout and release period that was years, multiple years, to, I'm talking to companies today that are releasing software 6, 7, in some cases greater than 50 times a day, right? So, I mean, a huge shift from where we were 30 years ago to where we are today. If I told the old me back in, in the 90s that this was the way applications were going to be developed today, I probably would have thought I was crazy. But unfortunately, I wouldn't have been. And here's where we are. So the difference in cloud native applications today is that their footprint is constantly changing. They're broken up into small pieces, these microservices that are all tied together to provide a service chain, or to glue together back an application that you can use, whether it's, mobile banking, or going on Facebook, as Jon was just talking about. And not only that, they're highly available applications that are meant to scale out very wide. So all their microservices can scale in very small increments. And they're also hugely valuable to the business today. And that's the reason why they need protection. But the data protection methodologies of the past, where everything was tied to actual physical resources, they just don't work anymore, because no longer is there physical resources. My application might be on this server 1 minute and on a completely different server. In things like Kubernetes, or even in OpenStack, it doesn't matter. It's not about the physical resources, it's about the virtual resources that we provision. And so this is why Trilio was brought about, because most of us came from a traditional infrastructure background. A lot of us worked at EMC at one point. I'm based in Boston. EMC is also based here. So there are a lot of people that work for EMC, and most of us have worked for EMC at one point in our career. So we're very well versed in traditional infrastructure. And our founder looked at OpenStack when it came out and said, okay, the cloud's going to change everything, and we can't do what we were going to do before. So this hybrid and cloud infrastructure has brought together a whole different way of provisioning resources, and traditional data protection methodologies can't protect those resources. And they also can't provide the RTO, so the time to recover that businesses require. And the reason for that is agents are all about physical boxes, right? No longer is this about physical resources, it's about logical resources. So we need to get away from an agent-based methodology and go completely to agentless methodology. Also, these platforms are all about multi-cluster, multi-tenancy, right? There are many physical resources. They're all logically carved up, and there may be many different customers using the same physical infrastructure. So we can't back things up from a physical standpoint. We have to understand who these tenants are, and we can't be mixing access to their backups just like we don't mix access to their VMs. We have to understand those things. Furthermore, everyone's used to being able to provision their own resources today. You don't have to go to an IT department anymore, in most cases, to provision your resources. So you should be able to provision and consume your backup just like you consume all your other services in the cloud. Backup should just be another one of those services. If you'd like to back something up, you should be able to do it by yourself. So we have to be integrated into the UIs so that it's easy for people to understand, one, how to use it, and two, to be able to consume it whenever they want. Also, the cloud is incredibly elastic, right? Everything's about elasticity in the cloud. It can scale up, it can scale down. And so we have to understand that scale, and we have to be able to afford it, to provide it just like all the other services in the cloud. So the backup platform itself has to be linear. I think everybody's sick of talking about backup windows. I used to spend a long time talking to customers about backup windows, and they were constantly asking me, John, look, my infrastructure is growing, my data is growing, my backup window is shrinking, so how can I hit my backup window? And unfortunately, it's hard to have a conversation about people with how they're going to get around the speed of light in physics. It's just not possible. So we decided to do things completely differently so your backups are not non-disruptive. So your backups are non-disruptive. It shouldn't be a zero-sum game as whether I run my application or I back it up. You should be able to do both. As well, we're big on open source technologies. We have integrated into open source technologies, and we believe in open source principles. So we have an open universal backup schema. None of our files are gated off from you. We believe we're backing up your data. Your backups belong to you, and you can read them forever. So that's a little bit about what we are doing differently. Let me tell you about Trilio Vault for Kubernetes, which is our newest platform. We're really excited about it. We released it, it went GA right at the beginning of July. We just released version 2.0, which has a lot of great features in it, and we're very excited about it. Before I go into it, I will tell you can get a free trial of it right on our website. If you go to trilio.io, you can download it, fill out a form, generate a license, and try it yourself. We even have online labs. But now that I've got done with my marketing pitch, let me tell you about the application. So as I said, we're trying to actually integrate into the platforms we're protecting so that you can have a service available to you. And so Trilio Vault for Kubernetes is actually a Kubernetes application. It runs right inside the same cluster that it's protecting. But it's not really protecting the cluster, so to speak. It's protecting the applications that run on it and the Kubernetes objects. So if you're using upstream Kubernetes or Rancher or even Amazon EKS, right, you can use Trilio Vault to protect your applications. And what Trilio Vault is like I said, an application that runs with a Kubernetes operator. And how you deploy that, it's very easy. You use a Helm chart, which will deploy an operator, which deploys our application and registers some custom resource definitions, or what are known as CRDs, inside of your cluster for self-service capabilities. So anyone that's used to using Kubernetes from a command line basis would be very familiar with this, because you can do things like kubectl git backups. And what a CRD is it's a way of extending the resources inside the cluster. So now all of a sudden Kubernetes knows, whoa, I have this backup capability. Whoa, I have this restore capability. I have the ability to provision targets and see backups. So you really have the ability to use backups like it's a piece of your platform. And as well, you may know of Kubernetes compatible projects, right, which are also registered with the Cloudnative Computing Foundation, things like Red Hat's OpenShift. So we have taken the time to integrate and are the only backup and recovery provider that's certified for OpenShift. And we have an OpenShift certified technology that shows right into the Operator Hub dashboard inside of OpenShift. So it's very easy to use. It takes about 4 clicks to install us in your OpenShift cluster. So no matter what you're using, whether it's one of those compatible versions of Kubernetes or it's Kubernetes itself, you can use Trilio to protect your application. Let's talk a little bit about how we do that, though. I mean, I know this is a very technical audience, so let's talk a little bit about Kubernetes and how Trilio actually integrates in it. So we like to think of Kubernetes in basically like 3 planes to keep it, kind of simple. One is the user interaction plane, where you as a user are interacting with Kubernetes as a platform. Another one is the control plane. Kubernetes has a very robust control plane. And as an integrated application and service, like I said, we're actually integrating with those CRDs. We have our own control plane that runs co-resident with the Kubernetes control plane. And then lastly, where Kubernetes is really evolving is with persistent data, which wasn't something that Kubernetes was very full-featured around in the beginning, but is getting much better. And so the last plane that we think about is the data plane. And that's actually where Kubernetes is storing things like persistent data in the back end through things called persistent volumes. And so if we're thinking of the user interaction plane, really to get back to the beginning of it, this is where we launch that Helm chart. And the Helm chart will spin up the Trilio Vault operator, which is depicted here as well. Now, this Trilio Vault operator here is responsible for managing the Trilio Vault application. So it self-heals the Trilio Vault application and makes sure all of its components are running. And when you give that Trilio Vault operator a actually version of Trilio Vault, it will spin up that version of the application in your cluster. It also enables you to be able to do rolling upgrades of the application. So it's very easy to manage this over time. But from a control plane perspective, we're really responsible for managing all of our custom resource definitions. Like I said, we're integrated fully into Kubernetes, which includes the Kubernetes API. So you can make calls to Trilio Vault resources like their Kubernetes native resources. That was that kubectl get backup that I was talking about before. And when you're asking Kubernetes, give me a list of backups like you would with that command, it's talking to the Trilio Vault control plane and saying, Trilio Vault, give me the list of backups that you've taken for this particular namespace, or whatever it might be. And so you have the ability to interact with our application in a native way. And also at this level, most Kubernetes resources are just objects defined by YAML or defined by JSON. And so we have the ability to back up those objects. Those are all stateless objects. Because we're interested in application protection, we want to back up those stateless pieces as well, because an application is many, many, many stateless objects tied to some persistent data on the back end, or maybe not persistent data. But we're going to back up these objects with like orchestrator pods, basically, that are going to orchestrate the backup of all those metadata files. And we're going to store them as JSON on an external repository. So again, we're trying to protect Kubernetes, and we're going to move this data over to a repository that's owned by you. It can be anything that speaks the NFS or S3 protocol. So again, eliminating that vendor lock-in. Now to move on to the persistent data, really, this is where we're going to actually back up PVs. And we have a portfolio of patents that describe our process for backing up persistent data. And so what happens is we've chosen to integrate with the Kubernetes container storage interface. The container storage interface, or what's known as CSI, is a standard methodology for enterprise storage solutions to integrate into Kubernetes. And so it gives us wide use of many different types of storage providers. And how we do that backup is basically we're trying to offload everything from the production application so our backups are non-disruptive. Again, like I said before, throw out those backup windows. You don't need them anymore. But what we're going to do is we're going to take a persistent volume that's attached to your application, and through CSI, we take a snapshot of it, And we use that snapshot as a basis to create a temporary volume. So what we're doing is offloading everything from the production application. There are no application sidecars or nothing to put inside your application if you want to back it up with Trilio Vault. When we take that temporary persistent volume that we created, we spin up a data mover pod. That's an ephemeral resource. It's only alive for the life of one backup. And that data mover is responsible for taking a QCOW2 image of that PV and storing it at the backup repository, the same one that we had written the JSON files to previously. And that QCOW2 file, again, is a completely open format. QCOW2 is part of the QEMU library, also part of KVM, which is Linux native. Now, when we're talking about actually extending the resources of the cluster itself, of the Kubernetes cluster, we were talking about custom resource definitions, right? And so when we're teaching Kubernetes about backups and teaching it how to understand how to back up its own applications, we're registering these resource definitions inside of Kubernetes. So now Kubernetes knows I have a target available. A target is just somewhere to store backups, like I said, NFS or S3. We also have the ability to define policies. So these are policies inside of your environment, things like backup and retention policies. And then also hook scripts. So some applications require quiescing before they get backed up, and hook scripts allow you to do that. We also have a backup plan, which is a way to define an application and say, I'm going to take this application, whether it's a Helm, label, or operator-based application. This completely differentiates us in the Kubernetes backup market because we can speak the same language as your DevOps, as your application developers, because they're developing applications as Helm charts. They're developing as operators, or they're developing custom applications that are defined by labels. And this backup plan takes that application and says, I'm going to write it to this target, maybe at this policy if I want to specify one. So at this schedule and this retention policy, and run these hook scripts if I have sensitive applications. And from that, what you get is a backup. And it can be full or incremental, right? It's up to you what you want to do. You can take a backup at any time. You don't have to run them on a scheduled basis if you don't want to. And then you have the ability to restore those backups whenever you want, right? This is another custom object inside of, or custom resource, I should say, inside of Kubernetes. And you can restore those backups to the same cluster or to a different cluster on any version of Kubernetes we support. So you can take an upstream backup Kubernetes and restore that same application to Red Hat OpenShift, right? So it's pretty neat. We allow you to do migrations to many different cloud infrastructures. And from that, you get back your whole application along with its persistent data. Now, when we're talking about actually protection and recovery of applications, like what are we protecting? In Kubernetes, there is many different types of objects that an application may be consuming. Some of the common ones are things like pods or deployments. PVs are the persistent volumes. There's also application secrets that can be stored right inside of Kubernetes. So these are things like passwords, things of that nature, API tokens. There are also config maps. There are replica sets. There are lots of different objects, stateful sets that we can back up. And we store all of that information as JSON files. And the PVs get stored as QCOW2 images to a repository that you define. Again, it's owned by you, and so is the data on it. And we can restore that entire application to a different namespace in the same cluster, or even to the same namespace if you want. But what's really powerful, and I talked about it before, is our ability to be able to do a location-based restore, which allows you to take any application from any version of Kubernetes that we support, again, including things like OpenShift, and restore them to another cluster. You can do this from upstream on-premises to Amazon EKS, which is Amazon's Kubernetes service in the cloud. So you have the ability to do kind of a hybrid cloud migration, or even stretch your applications across different infrastructure if you need to, which is a very common use case, but is difficult to enable with Kubernetes. So Trilio Vault can help you do that. And so what are we backing up when we're talking about Kubernetes? Well, I talked about defining those applications by custom labels. And Kubernetes, if you're not familiar with it, has very robust labeling capabilities. You can label anything with as many labels as you want. And we can parse for those labels and back up any objects where they match. So we can back up all that JSON metadata and then the QCOW2 from all of the PVs. So that's very powerful, but there are several different backup technologies that allow you to do that. What really differentiates us is being able to integrate with the way you're rolling out your applications, because we can back up your Helm charts, which are pre-rollout of an application. A Helm chart is the basis for rolling out applications inside of Kubernetes. And so when you back up your Helm chart, you really have the ability to be able to transform that going forward whenever you want to do a restore of the application, because we're backing up everything pre-application into Kubernetes, I guess is the best way to say it. And not only that, with Helm charts, we'll actually back up all of their revisions as well. So you really have a complete time machine, you can think of it, for your applications in Kubernetes. Now, we also have the ability to back up operators. Operators are, I guess you could think of them as a more mature way of rolling out applications, because operators have the ability to actually operate an application. The name operator comes from the fact that they were designed to be the human, or the software embodiment of a human operator. So they really have the ability to manage the application itself, just like we do with our Trilio Vault application. And we can back up that operator and any custom resources that go along with it. So that kind of ends the Kubernetes portion of the conversation. So what I would like to kind of segue to, I suppose, is the Trilio Vault for Openstack. So take off our Kubernetes hat and put on our Openstack hat for a little bit. And we'll talk a little bit about Openstack, which is very near and dear to our heart, because it was our entrance into cloud native backup and recovery. We've had this solution around now for the better part of 5 years, and possibly even slightly longer than that. So anyone that's familiar with Openstack, and I'm sure there's quite a few people listening to this that are familiar with Openstack, knows it's a clustering of services. I believe today in upstream Openstack, there's about 42, maybe 46 different services you can install in your cloud. And we integrate as a native service to Kubernetes, Openstack as well, to provide backup and recovery. So just like Keystone provides identity service, or Nova provides compute and virtualization, Trilio Vault, once installed into your Openstack cloud, provides data protection, backup and recovery as a service inside of your cloud, all right inside of the Horizon dashboard as well. It's very easy to consume. And when we had originally conceptualized the platform, we were doing it all around being OpenStack native, right? And with a lot of the things that I was talking about in my last kind of setting the table slide, where we're going to be agentless and understand multi-tenancy, understand Keystone permissions, and do everything in a non-disruptive way while not locking you into our platform. And when you're thinking about OpenStack architecture and how Trilio Vault actually integrates with it, you'll notice that we are going to be part of the OpenStack architecture. So, Trilio Vault is going to actually join itself to the control plane. We have a virtual appliance, and we'll join that control plane, and we'll talk to it just like we're a integrated service into OpenStack. So really what we're doing is we're standing up our own control plane components that are completely out of band when it comes from backups. What we're going to do is generate our own service token to become part of the cloud and roll out our own API. Again, we'll be all API first, just like OpenStack is. And from there, we actually use a data mover that runs as a service on the compute nodes themselves. And this data mover isn't actually doing any of the backups itself. It's actually orchestrating components that already exist inside of OpenStack. Now, I would be remiss, I know Canonical was speaking earlier today, if we didn't mention the excellent work we've done with Canonical through a partnership inside of OpenStack. And what we've done is we've taken all of the Trilio Vault services and we've turned them into native OpenStack services. So if we just go back for a second, you'll notice we have this control plane component with a VM right here. This virtual machine is actually the Trilio Vault control plane that's just dedicated to backups. We're not actually running as a native service inside of the OpenStack control plane. We're just logically joined together with the control plane via a service token for Keystone. But what we've done with Canonical is we've taken that VM and we've deconstructed it, turned it into services and containers that can run right co-resident with the OpenStack control plane and are all rolled out with Canonical's Juju methodology. So it's very integrated into the life cycle of OpenStack itself. And so, when we're thinking about how OpenStack and Trilio Vault work together, really, we've turned Trilio Vault into a complete control plane component inside of Canonical. And a lot of kudos goes to Canonical because they did a lot of the development work themselves to get Trilio Vault kind of deconstructed and running co-resident inside the control plane. So, for people who are using Canonical's version of OpenStack, you really have the ability to be able to bring an extra level of ROI and TCO to your applications when you're running Canonical OpenStack. And it also, integrated into Juju is a rollout of the data mover components that live on the compute nodes themselves. So there's a great level of partnership between us, and I think we're really bringing value to Canonical's customer base as well. And as well, inside of OpenStack, one thing I didn't mention is our ability to store our backups on customer-owned infrastructure as well, because what we want to do, again, inside of OpenStack or inside of Kubernetes, is to make it easy for you to keep your backups forever and to always be able to use those backups. So we're going to be storing them on customer-owned infrastructure that hopefully you'll have forever. So I didn't want to go too in-depth, but I did want to say a thank you to everyone. This is the end of my presentation for having us here today. This is my email address, my Twitter handle. If you want to reach out for anything, I'd be more than happy to answer any questions that you have after the presentation. And thank you, Babar and Hisham, for having me here today.
thumbnail दे और मैंने कहा इमरान बिल्ली निकाल
This is really fantastic. So lovely. You're also doing for something for Kubernetes as a backup solution.
Yeah.
So we had a discussion that you have a plan to launch this service in coming months. So it is here. Lovely to hear that.
It is, yeah.
It was brilliant, John. It was brilliant. You know what? We had a few presentations since morning, and the comments on this one just spiked up for a strange reason. Maybe it's John, maybe the training, maybe it's, so it was brilliant by all means.
Yeah, thanks. We're excited. It's been exciting times at Trilio. We just announced our next round of funding as well, so we're well positioned to go into the future. And there's been a lot of uptake in the market for both of these solutions. We have a great customer base. We have a lot of great partners. So we're very lucky as a company and I as an employee to be where we are today.
Who don't know what is these things are going to do with their infrastructure. For example, if they are a freelancer, if they are doing some graphic designing, if they are just blogging, or if they are just posting their pictures, they don't know how the system is making backup of their data. So this is the solution, what John has mentioned over here, that is going to actually back up your data. So this is the assurance from the Trilio. So your OpenStack backup, OpenStack instances or data is not going to lose anywhere.
Yeah, exactly. And I think, one of the other things, Babar, that I've talked to a lot of people that, there's a lot of press out there about ransomware. There's a lot of people that are afraid of ransomware today, right? I mean, everybody is really concerned that this may happen to them. And the great thing about enabling the infrastructure like we do is that, if you're using a VM and your VM gets compromised, it doesn't know anything about backups. The VM has no clue that it's even being backed up. So the first thing that happens with ransomware usually is they'll go in, they'll encrypt your backup target so you can't restore your applications, right? But the VM doesn't know anything about backup, so they can't encrypt it, which is great. It's an easy way to hopefully help protect yourself. Now, of course, hackers are they're crafty people, so there are some caveats to that. But hopefully, we're talking to a lot of customers about helping to kind of protect them and how we can obfuscate those resources. So.
Yes, and especially the solution you have mentioned over here with the Kubernetes. Nobody knows how to save the data on Kubernetes, whether it's a PV, whether it's a namespace, whether it's a host or a container or anything else. So this solution might help us, or I'm sure it will help us to have the whole Kubernetes infrastructure running in some other place after making restoring it from a backup solution. Is that correct?
Yeah, absolutely. I think, when you're looking at Kubernetes, it's hard. When we talk to customers, a lot of times they're saying, like, most of my application's stateful. It's easy to just respin it up, right? I don't need to worry about restoring it. I just recreate it, which is true for some things in Kubernetes, and for anything stateful, that's probably what you would do. But there are a lot of stateful workloads today that are looking to move into Kubernetes, because the applications are developed in Kubernetes, so they want to roll their databases out with Kubernetes as well, because it makes for a much easier pipeline and integration into a back-end database. And when people are looking at their applications, they have to understand, and when we talk to people about the application has a state on a particular day. Yes, you release many different versions of your applications. You do those things frequently as well. But what is happening is your application on day one has a state, and then on day 3, when you've made 10 releases between day 1 and day 3, it has a completely different state. And that database is the embodiment of your application's state. So when you go to restore those stateless pieces and tie them to a different version of the database, your application isn't going to start up. And so if something does happen to your infrastructure, what you want is the quickest path to recovery that you have. And a backup where you're tied to your PV is going to be the quickest. And not only that, I mean, it was just, what was it, yesterday morning, Google had a bunch of disruption in their services. These cloud platforms are not bulletproof, right? Now, do they go down often? Absolutely not. And hopefully they never go down. Like, I don't want anybody to suffer downtime. I just want to make sure they're protected on the other end of things. And that may happen, right? These cloud platforms may go down from time to time. If you have a cloud target with Trilio, you can restore to another cloud service, another Kubernetes cluster running on EC2 or on Microsoft Azure or running in your own data center, right? So we just want to help them protect their business.
Yes, it truly said that this is going to be a very, very good solution for all of us, and I'm looking forward to it. We are working with you guys. I really want to show this service to our service providers in Pakistan and in Asia, so they can also save their infrastructure with this bulletproof wallet for OpenStack and for Kubernetes.
Yeah, we're excited. And again, if anybody wants to try it, we have online labs, so you don't have to actually install anything. They have live AWS instances running behind them, so you can go and actually kick the tires in the application, see how it does backups and restores. And for less than 10 nodes, it's completely free forever. So if you're running a dev cluster or anything like that, it's free. Yeah.
Okay, I'm gonna talk to Ross about that.
Sounds good.
I really need that one for us. Yeah. Fantastic.
Bob will not let any opportunity pass by. That's Bob.
There's nothing wrong with that.
But that is very important for our people in our country, that they would like to have these kind of solutions, because everything is changing in the world. So why not we change ourselves to learn new technologies, to learn new things, what is happening around the world?
Absolutely.
Yeah. So Ross, thank you very much again for this wonderful session by Jon. Jon is a remarkable. He did fantastic presentation for us. And if there is a question for the guys, I'll try to answer those questions at night. Hisham, we will have a session after the whole.
Of course. I just gave them my word that we will have this YouTube appearing on a screen, and V2 appearing on a screen, and then they all can hop in and ask their questions. And hopefully, if they ask good questions, we got you to answer.
Yes. So if there is some question, maybe we can ask from John and Ross.
There's one question
Yeah.
from the lady, and I would like that to be printed on screen because that's very important question. It was about, it came from Sabah Ashraf. No, it's not Sabah Ashraf actually. It came from Asma Sajid. And there you go. How much time will it take to take backup and restore the new version? Is there any specific lag time, John?
Yeah, so I think probably talking about an application. So how long does it take to back up and then restore an application? Yeah. So it's not magic that we're really doing here. So a lot of times it's all about physics, right? The longest part of a backup process is usually the persistent data itself. Whether we're talking about OpenStack or we're talking about Kubernetes. So it's usually a function of network bandwidth and response time in the network. We see backup speeds that are as quick, as 2 or 3 minutes, but it really is going to depend on how big the application is, right? That we're not talking about a huge scale out Hadoop cluster here. We're talking about, maybe a 50 gig database or something like that. But the recovery times are remarkably quick. I mean, think of the amount of time it would take to copy that data to wherever your backup target is and then copy it back, plus maybe about 2% overhead, depending on how big the application is, to do the metadata restore.
Lovely.
Which is pretty amazing and quick. Just like we saw yesterday, the Google had their downtime, perhaps for the very first time in 20 years, but because of this backup systems, they were able to come back without raising much eyebrows, because a lot of speculation on Twitter was going around to the route of the Senate pinning or trying to pin down Facebook, and they thought that all of a sudden probably Google has taken a hit first before Facebook could be brought in the line. So there was a lot of speculation. If you go and go through the tweets about the downtime yesterday, and there were some interesting memes about Google. At the end of the day, there's one question, John, and it's irrelevant. We have seen Facebook going down. We understand that Facebook has got around 2.6 billion users, higher than the number of cars on the roads and planes in the sky all over the world. So it's huge. Given if all the accounts are original ones, not the fake one, but that's subject to separate discussion. We talk about Google. We saw what happened to Google yesterday. What is it with Twitter? Never goes down, never gives up.
Yeah.
I think this is something very interesting. Is that some different technology that is being used at Twitter? So I'll have you, brainstorm and give your 2 cents on this.
Yeah, it's a good question. There's a lot of, if you think of Netflix, right, which has had some pretty high profile and disruptive downtime over the last maybe 5 years. Ish, right, due to different AWS services having disruptions, right? They had some load balancer problems, things of that nature. I think, my guess, again, right, we don't all know the answer to this question, is they're pursuing a multi-cloud strategy, right? That is the only real way to get around service disruptions in different platforms, right? I mean, Google, you just mentioned it, has had some pretty disruptive downtimes due to things that they didn't understand about their own infrastructure, right? As human beings, there are always things that we don't know. There are known unknowns, right? And there are unknown unknowns as well. And those are the ones that always bite you, right? I know, a couple of years ago, Google had an outage that was caused by their control plane network becoming unreachable. So that everybody relies on the control plane network, right? That's the thing that you can always get to the control plane, right? To fail over the cluster, go to a different cluster. But when your control plane network is suddenly unreachable, You have no
Wow.
way to recover, right?
No way to do anything.
Yeah, exactly. You know, they lost their ripcord, right? You know, their primary parachute didn't open, and they went for the backup, and they were like, "Oh, we forgot to pack it." Oh man.
Yes. And by the way,
it's gonna be a rough landing.
yes, by the way, 3 weeks ago there was a disruption in Azure Cloud as well, because I'm working. Well, my company is working for some companies in US, and they are using Azure. So they had a disruption, but that was a midnight in Pakistan, so nobody knows what happened at that time, except guys like me who are actually working with them to fix the issue.
Yeah, right. I mean, but businesses today, you know, Babar, to your point, they're run 24/7, 365, right?
Yeah.
I mean, the Google disruption wasn't really necessarily a big thing for me because I'm in the United States, but for Pakistan, it was probably a pretty big deal, right? Because it was like right in primary time for you guys. Like I was just waking up and they were kind of solving it, so it wasn't really that big of a deal for me. But
you're very right. You're very right.
You know, they can't wait. You know, it's not. There is no like non-disruptive time anymore.
Right. Yeah. Billions of people, you know, they got an eye and they're using the services. So you can't even afford a downtime if you're huge. And you only become huge if you are particular about your uptime. And that's how, you know, I balance the whole equation of running a disruptive startup and making sure that people are glued to it, people are actively using it. And what we saw yesterday was probably a perfect example of a quick call to action. And a lot of startups probably are watching this stream right now. Jon has elaborated and highlighted the importance of having a good backup systems and clusters and make sure that and taking a leaf out of the Twitter book. I don't want to sound as a commentator's curse here, only to find out in the next hour Twitter goes down. Don't blame me if this happens. But for now, we have seen every giant go down except Twitter.
Really well said, Hisham.
So Jon and Ross, thank you for bringing in Jon. Jon, it was great experience, wonderful training, and you're a rock star, bro.
Yeah. Oh, thanks. I appreciate that. I appreciate you guys.
Fantastic guys.